Good day, everyone. This is the Chapter 11 Running Water by Group 11, and I'm your first reporter, Kathleen Pinaria. These are the objectives for this discussion or topic. First, we have a photo here. This is the Nile River in Egypt, stretching about 6,650 kilometers. This is the recognized longest river in the world, and in Egypt, it plays a central role in supporting life, and most of the country is desert. So the Nile floodplain and its delta form the only major areas where agriculture is visible. For thousands of years, the Egyptians have depended on the yearly flooding of the Nile, which deposited rich silt on the farmlands. This natural fertilization allowed crops to grow even in a dry environment. Introduction: The power of running water. We often experience the force of moving water when swimming or canoeing in a fast flowing river, but the real power of the running water becomes clear during major floods where water can move with tremendous energy. A dramatic example was the Johnstown flood in Pennsylvania on May 31, 1889. At 4:07 p.m., the residents heard a roar like thunder. In only 10 minutes, the town was struck by a massive 18 meters high wall of water traveling at 60 km per hour. Then the flood was caused by intense rainfall combined with failure of an upstream dam, and the disaster killed at least 2,200 people, making it the deadliest river flood in U.S. history. Then many homes, buildings, trees, and the entire family were swept away. Second example is the Indus River flood in Pakistan 2010. Unusually heavy monsoon rains caused the Indus River to flood. Water covered around 10% of Pakistan, affecting millions of people and causing at least 2,000 deaths. It was one of the most widespread flood in modern history. Next one is the Brisbane flood in Australia 2011. So following the flood in Indus River is this one. Heavy rains from tropical cyclone Tasha led to severe flooding, and more than 90,000 and 200,000 people were affected, with damages estimated at 1.8 billion US dollar. Lastly, we have the Mississippi River flood in US 2011. So in the same year, an intensive flooding occurred along the Mississippi River, one of the largest floods since the historic disaster of 1927. Water on Earth. Most of the Earth waters, about 97%, is found in the oceans, which means it's salty and not directly usable for drinking or irrigation. And the biggest portion, is about 2% that is locked up in ice or glaciers and polar ice caps. Then the tiny remaining 1 to 2%, what we usually depend on for everyday life, that is the 1 to 2%. And it is found usually in river, lakes, groundwater, swamps, and even in the atmosphere as water vapor or clouds. So although the amount of water in rivers and streams is very small compared to the total water in Earth, it plays a huge role in shaping our planet's surface. So why running water is important? Streams and rivers shape the land by the erosion. Erosion is the wearing away, or it wears away rocks and soil from the Earth's surface, carving valleys, canyons, and gorges. Next is the transportation of sediment. This is the carrying of sediments such as sand, silt, and gravel downstream. And then the deposition. This is the final destination of the transported materials or the eroded materials. In short, erosion is the one that cut or break. Transportation of sediment is the one that carries, and deposition is the dropping the transported sediment. Streams and rivers are dynamic systems. They are not static, meaning they constantly adjust and respond to both natural and human-made changes. Hydrologic cycle. This is the continuous recycling of water from the ocean through the atmosphere to the continents and back to the oceans, or from the oceans through to the atmosphere and back to the oceans. The process starts with the evaporation mainly from the ocean, and this provides about 85% of moisture that goes into the atmosphere, and then the remaining 15% of water vapor comes from the land, like lakes, rivers, soil, and plants. But the water originally came from the oceans too. So these are the basic three steps cycle over the ocean. Evaporation, it is when the water turns into vapor, and then condensation, vapor forms clouds in the atmosphere, and precipitation, rain or snow falls. Then about 80% of precipitation falls directly back into the oceans. Always dyan na siya mo balik sa ocean ang water. And then extended cycle over the land. About 20% of precipitation falls in the land. This includes the evaporation, the condensation, the movement of water from the oceans to land, then precipitation, then runoff, which is the water returning to oceans through streams and rivers. Fluid flow. Solid versus fluids. So we know this already. Solids are rigid and keep their shape unless a strong force deforms them. On the other hand, fluids are liquids and gases that cannot hold a fixed shape. Solid like a rock, gibutang siya sa usa ka place, dili siya ma-move or break if dili siya i-push or tandugon. And in fluids, if water is uphill, it will go downhill because of gravity. And even as gamay rag tandog sa tubig, it will move, it will flow. Just like this, they flow easily when any force is applied, even a very small one. Then surface runoff is the water that flows over the land during rain. So, ang kaning runoff is mao ni siya ang kanang water nga wala na absorb sa soil during the rain because it may have a heavy or very long rain. And the key factor of this is the infiltration capacity. So the infiltration capacity, in a simple word, it means how much water the soil can soak in or absorb. If the water absorbs water quickly, there is a little or no runoff. But if ang water kanang dili na ma-absorb sa ground, meaning ang water must stay sa surface and then the runoff occurs. These are the affecting factors in filtration capacity. First is the rainfall intensity and duration. If ang rain is light and then short, the soil will absorb it, meaning no runoff. But if the rain is heavy and then long, the soil cannot keep up. So ang water is mo build up and the runoff begins. Next is the soil moisture condition. If dry and loose ang soil, meaning many empty spaces, then water can just absorb the soil can just absorb the water fast. And then if wet na gani siya in compact soil, meaning ana tightly packed na siya, then the soil will absorb it slowly or maybe not at all because puno na siya. And then the runoff begins sooner. Then the soil saturation is, once the soil is fully saturated, it cannot absorb more water. Running water refers to the water that flows over the earth's surface or through the ground under the influence of gravity. It is one of the most powerful agents of erosion, transportation, and deposition that shapes the earth landscape. So, we discussed this already, the three major functions of running water. First is the erosion, the one who wears away soil and rock, carving valleys and channel, then creates major landforms like the Grand Canyon. So, siya ang break mukat sa mga soil and rocks. Next is the sediment transport, the carries particles ranging from the fine clay to large gravel then moves sediment over the long distance. Muna siya ang magdala sa mga gipang break na soil and rocks. And then the deposition, when the water slows down, it deposits sediment, forms large features such as Mississippi River Delta. So, katong mga gipang dala nga mga sediments is ma-drop na to sa a specific area, then as time passes by, mahimo siya another landform. We have the sheet flow and channel flow. Sheet flow is a thin, continuous layer of water moving over the land surface. It is not confined to channel or depression. So, sheet flow occurs after the rain. Mao ni siya ang mga thin layer of water nga na spread out sa a large area of the earth surface. Kanang na spread ra siya without kanang flowing sa usa ka direction or usa ka path. Kay lahi naman po na siya, channel naman na siya if mo flow siya sa usa ka path. So wala siya define to channel or depressions. I mean, there is no confined to channel or depression. And then key features cover the grounds like a sheet. So i-cover niya ang ground, ang whole ground or large area of the ground after the rain. And then occurs before water concentrates into channel. This occurs before siya mo padung sa channel, nagkatag sa na siya ang kanang very thin layer of water, and then most relatively slowly and over widespread. So dako gyud dihang ma-cover nga area, wide at the same time slow. Kay kung fast na siya sa channel na. And then the importance is that it causes sheet erosion where thin layers of soil are removed. So, tungod sa pagstay niya sa above the surface, naa siya gamay nga kanang ma-remove or makat nga mga soil, kanang ma-appeal pod sa iyang pag-flow. The significant issues in agricultural areas, especially where soil is exposed. Next is channel flow. When surface water gathers into trachlite depressions, it forms a channel flow. Channel vary from tiny rills to massive rills like the Mississippi and Amazon. Channel flow happen when the water gathers together and then start to flow in a defined path. It may start with a small or tiny rills to the huge or large river. And an example of channel types is the rill. This is a very small channel formed by trickling water, and then brook or the creek, a small steady flowing channel, and then stream or river, a larger flowing water bodies. These are the types of channel. And then the characteristic, water flows become faster and deeper. Erosion potential increases significantly. Since naa naman siya kanang agianan gyud defined path, meaning ang flow sa water is very kusog na kayo and faster, and then deep jud iyang agianan anak. Dili same sa sheet flow nga slow ang movement sa water, and then kanang naara gyud siya sa top sa surface. Ang channel is kanang agianan gyud sa tubig nga kusog iyahang velocity and then very deep, maong naa say erosion nga mahitabo ana nga part. Then kusog kay na siya mo mudala or mo break, mo cut sa mga soil or rocks sa ilalom, because the velocity is faster and it is deeper. And then the sources of water to streams and rivers. Streams and rivers receive water from multiple sources. First is a sheet flow. This is a very thin layer of water that eventually drains into the channel. And then direct rainfall, meaning ang rain is directly siya moadto sa stream or the river channel. And then the soil moisture and ground, which is the most important one, and water stores in soil moves downhill. Kanang mga water nga na stored sa soil is ma-move jud siya downhill kay tungod sa gravity. And then the ground water discharge feeds streams and rivers continuously. Then this makes flow more stable. So we proceed to gradient velocity and discharge. Gradient is the slope of a river, how much the river drops vertically over a certain horizontal distance. It shows how steep or gentle a channel is. So let's consider this example. Gradient is equal to the total vertical drops, which is 1,000 meters, and then divided by the horizontal distance, which is 500 kilometer, meaning gradient is equal to 2 meter per kilometer. So that is the slope. And then it's important is that gradient is steepest near the headwaters or the source of the river. Ang meaning anang near the source is the starting point of the river, which is usually in the mountains or highlands, and can be tens of meter per kilometer. And then the next is gradient becomes gentle near the mouth, meaning the place where the river ends, which is usually at the sea, lakes, or another river. And this may be only centimeters per kilometer. We proceed to the velocity. So we know this already. Velocity is the speed of flowing water or how fast the water moves downstream, and this is usually expressed in meter per second or feet per second. Velocity varies because of friction. First, water moves slowest near the bed and banks due to friction, meaning slow mo move ang water near the bed or the bottom or the banks because of friction. And if near sa center and surface of the channel ang water, then it moves faster. So these are the factors that affects velocity. First, the channel shape. So first is the broad and shallow channels. If broad and shallow imong channel, then most likely more water will touch the side, and then more ihang friction will result to slow flow. Like katong akong gi-state ganiya katong first that varies friction. And then the next is if narrow and deep channel, meaning less iyahang contact, so less iyang friction, meaning faster iyahang pag-flow sa water. And then fastest iyahang flow sa semicircular channel because there is less friction. Second is channel roughness. Rough channel that kanang consist of boulders and rocks, meaning kanang taas kayong friction kay daghan man siya rocks, that will result to slow and turbulent flow. And then if the channel is smooth, which consists of sand or mud at the bottom, meaning faster iyahang pagflow. Next, we have discharge. Discharge is the amount of water flowing. Its formula is equal to the cross-sectional area times the average velocity and then volume of water passing a point per second, and usually measured in cubic meter per second or cubic feet per second. Discharge increases downstream due to more tributaries add water, then groundwater adds water, then surface runoff increases. And then discharge variations are the highest during rainy season and lowest during dry season, and then desert stream may lose water and disappear downstream. We have the running water, erosion, and sediment transport. First, energy of running water. Potential energy, we know this already. This is the energy of position. Kanang ready na mo mogamit iyahang energy. Waiting siya sa kanang mo push niya or waiting siya sa mogamit sa iyang energy. Yeah. And water of high elevation, mountains, hills has more potential energy. Like a ball at the top of the slope, it can move and do work. And then the kinetic energy is the energy of motion. When the water flows downhill, potential energy is converted to kinetic energy, and then faster water, the more kinetic energy, the more power for erosion and transport. Faster water because naa naman siya yung movement, kusog, from potential energy to kinetic energy. And then mas kusog diri mo dala or kanang breaking or cutting of the sand, of the rocks and soil, and then kusog sa ihang pagdala or the transported materials is being carried because of the faster water, which means more kinetic energy. Sediment loads carries by a stream. First, we have this dissolved load. So these are the minerals that dissolved in water, like salt and sugar, pero dili nato siya makit-an. They are invisible. Next is suspended load. These are the floating fine particles in a water that they keep floating because of fluid turbulence, and this gives rivers their muddy or brown color at the bottom. And bed load, or the heavier objects like sand, gravel, pebbles, and sometimes boulder. Mao ni sila ang mga dagko nga mga butang nga if move siya, mo roll ra at the bottom of the river. How running water erodes? So, the river erodes in two ways. First is the hydraulic action, or the power of the moving water. The direct force of moving water, then water pushes, lifts, and prays particles from the bed and banks or from the bottom to the side, and then strong enough to despoil sand, gravel, and even smaller rocks. So, hydraulic action is the removal of the loose particles by the power of the moving water. And then the abrasion is the sediment acts like sandpaper. Sand and gravel carried by the river scraped and wear down the channel, then produce smooth bedrock clumps and skin. So, abrasion is the process of whereby rock is worn smoothing by the impact of sediment transported by running water, glaciers, moves, or wind. So, next is the potholes around depression drilled by swirling sand and gravel. So, potholes are the round holes in the riverbed, and it forms when the water spins in a circular motion. Sediment inside grinds into the bedrock and creating rounded holes. And then, um, let's proceed to the erosion to transport to deposition. After the river erodes materials in two ways, we also have here the three steps after the erosion of the river. First is the picking up by the river or the erosion, and then the moving downstream of dissolve, or the moving of the sediment downstream as dissolved load, suspended load, or bed load, and then the deposition, which is the final destination of the carried materials, which eventually go to streams or lakes during floods or flood areas. Proceed to the deposition by running water. First is the braided streams. So as we can see sa iyahang picture, kanang kuan siya, murag gubot iyahang path. So daghan kaayo ang channels and split apart and rejoin repeatedly. So mauna ang braided stream, and this channel wave around bars of sand and gravel then look similar to the braids in hair of woven rope. And then these usually appear when the sediment supply is very high, and then the river very high, which the river carries more sediment than it can transport. Mangunang daghan kaiyahang kanang channel, and then the water flows in a variable or weak. During the low flow, the river cannot move all the sediment. And then its characteristics are broad and shallow, meaning ana the water spreads out mo gamaiyahang velocity, meaning mo encourage pod ang deposition. And then bar building, sandbars and gravel bars form, forcing water to split into multiple channels. Mo nang daghan kay siya og channel. And then because of the sandbars and the gravel formation, and then these are the type of the sediment deposition, mostly land and gravel. This is the opposite of braided stream, the meandering stream. As you can see in the picture, usa ra iyahang way nga paliko-liko, so that is meandering. Ang braided is daghan kaayo to. And the channel shape, a long straight segment, semicircular cross-section, then at curves, meanders, or symmetric in one side deeper, but on the other side it is shallow. Then flow behavior in a meander, cut bank, or the outer curve. The outer side of the bend has faster water, but if kanang faster sad ang water, mo cause siya erosion, and then the eroded bank is called the cut bank. Kay dito man mahitabo ang erosion. Then the next is the point bar or the inner curve. The inner side of the curve has slower water. Slower water allows sediment to be deposited, forms a point bar, a curve deposited of sand and mud. Kung asa slow iyahang flow sa water, dito pod mo gather ang mga gipang carry nga sediment. And then sediment characteristic are mostly sand, silt, and mud, then deposited on point bars. An X-bow lake is a U-shaped lake that was formerly a meander in an adjacent river. I-bow describes the U shape of the meander or curve snaking path of a river. So, over time, the meanders can become very curved or almost touching. If the meanders curve more and more, then eventually ang ilahang side is mo touch na sa each other, and during a flood the river may cut through the narrow neck, and then the old bend is abandoned. So katong mga old na nga bend, di na to sila mahilabtan or magamit. And then the old bend is abandoned. So katong mga abandoned bend, dili na to sila. And then the abandoned bend becomes a crescent shape. What happens to X-bow lakes? So for many years they will stay as a lake, but over time kanang it will slowly kanang mabut nga mga sediment soil, and then ang ending ani nila is mawa ra Japon sila, and then they'll form another land.